Yeah, good day, my viewers all over the world. I remain Sal Lumaj, and our subject today is mathematics. And under it, I'll be talking about linear inequalities. Inequalities, as the name implies, not equal. Or let me call it linear inequalities and number line. And number line. I've been talking about number line in some of our topics, even in physics, in chemistry. I spoke about number line when I was talking about talk about the organic chemistry. Where I was talking about greater than or equal to, less than, and different. Okay, but today I'm going to explain everything. So today we have linear inequalities and number line. How do we use number line to express or to explain a linear expression? You can be given a number line and they will ask you to interpret it. So today I'm going to give us questions on the linear inequalities, then we are going to represent it in number line. Good. So today, let's say we have before then, when you're talking about number line, what we always talk about there is this sign. This is less than sign, less than, and this is what? Greater than. And this sign, okay, let me just put it one after the other so that it can be well understood. So if I say greater than, this greater than is different from this. This is greater than, and equal to. I have to explain it so that you can understand it better. For instance, if I say x is greater than 4, x is greater than 4, and I put x is greater than or equal to 4. These two expressions are not the same thing. If I want to interpret this, the first value of x is 5. Followed by 6, 7, 2, infinity, positive integer. But if I say x is greater than or equal to 4, it means that the first value of x is 4, followed by 5, 6, 7. They always make use of this thing in your set theory calculations or questions rather, where they will not tell you that if x is greater than 4, and further by my student, please take note of this. And another one say x is greater than or equal to 10. What are the values of x? You just wanted to know whether you have the deep knowledge about the difference between this x greater than 4 and x greater than or equal to 4. Once you see equal to be part of the either less than the greater sign, it means that the number that has been quoted here will be the first number you are going to put, like what we have here. Our first number is what? 4. But what we have is just 5 being the first number because it's not equal. So the same thing applies if you have less than. If you have less than, let's say I have, this is less than sign, less than, and this is less than, and equal to. So if I say x is less than 3, and I say x is less than or equal to 3, so it means that the first value of x that is less than 2 is what? 3 is what? 2. So 2, 1, 0, minus 1, minus 2, minus 3, like that. So if I say x less than or equal to 3, it means the first value of x is going to be what? 3. 2, 1, 0, minus 1, and so on and so forth to the negative end of infinite integer. So that is that about less than and equal to. So let's start the number line proper now. So if you are drawing a number line, you draw from negative to 0 to positive. From negative infinity is always like this. This is your line. What I'm saying is that you draw from negative infinity, this sign means infinity, to 0. There's nothing like negative 0, there's nothing like positive 0. 0 is 0. So we move from negative infinity. If I say negative infinity, for instance, I can say this is -1, -2, -3, -4 to infinity. That is negative infinity to positive infinity. Positive infinity. So to positive infinity, then you can have 1, 2, 3, 4, 5 to positive infinity. So this is what we talk about, drawing a number line. Then you can now show your inequality on this number line. But I'm going to give us a question. But the question you're going to be given can be a linear equation. You can also be given a quadratic equation. Use the number line to explain it. They are very simple. Just follow my principle. Follow the explanation. Nothing is difficult when it comes to physics, mathematics, chemistry, or any subject. So far somebody has studied it. You that you are watching me, you can study it. One person has known mathematics, you can know mathematics. Nobody is born a genius. Here on earth, you become one. You become one. So don't let anybody bamboozle you that in their family, the thing runs. You can also start same thing. Let that philosophy or the psychology start from you, so that the thing will run in your DNA. Yeah. So I will give us a question. We have two. Let me give you this question. 2 into bracket x minus 5 less than 5 into bracket x minus 4. So we want to solve this question now. Then you now use number line to explain or to write. You leave your answer in number line. That's how they put it. They'll give you this equation. They'll tell you leave your answer in number line. I'm going to tell us some salient things you need to understand here, so that you don't make mistakes of sign, please. So you solve it the way you solve your regular linear equation. Where student normally makes it is when this thing will need to change because of sign. All right, let's go. I want to expand this. 2 times x, that is 2x. Please follow the way I expand what they call it, brackets. You can't mix it. Mathematics is about step. If you do your step well, you can't miss out. 2 times this plus 2, plus times minus 2 times 5, that is 10. So still less than 5 times x, that is 5x minus 20. This is plus 5, plus times minus 5 times 4, 20. So we are simplifying. So you simplify further. So for you to simplify further, you need to do what? To collect the like terms. And please, this is where students normally make mistakes. And I want to appeal to you that if you are solving inequalities, ensure that your alphabet, that is your unknown, always remain positive, so that you don't carry the pain. I'll do it in 2 ways. Now you understand what I'm talking about. You don't carry the pain of changing greater than to what? Less than. Like now, if you say, okay, you want to do this, collect the like terms. Collect the like terms. That is, number should be on one side, then alphabet on the other side. So if this one remains, you have 2x. This one will come and meet it. It becomes minus 5x. This one will leave this place. The less than will still be there. Then we have minus 20 plus 10. So this one is crossing to this side. So you're going to have minus 3x less than what? Minus 10. So you have to divide both sides by minus, so that you can get the value by minus 3. So that you can get x. Meanwhile, once you are dividing through by a negative number, this sign will have to change. So meaning that if I'm dividing through by 3 minus 3 by minus 3, this one will change to what? Greater than. So we now have this cancels this. So we have x greater than what? 3 whole number 1 all over 3. This is method 1. The other one I was saying that always avoid yourself of the mistakes is this. Just look at this place. While you are getting to this place, find a way that your your alphabet, that is your unknown, will be positive. Look at what I want to do. You know, by the time you collect line terms, you have checked from here that 5 is bigger than 2. So it means that the smaller alphabet will go and meet the bigger alphabet. Without you even just maintain the sign that way. How do I mean? It means this number will leave for this place. Why this 2x will leave for this side? Because 5 is greater than 2. So you're going to have minus 10. This one will come to this side, become plus 20. And this sign will still remain less than 5x minus 2x. So we're going to have, this is minus 10 plus this is 10. And this will now be what? 3x. Then you divide both sides by what? 3. Because you are not using any negative to divide anything. So this will cancel out this. So you have 3 over number 1 over 3 less than x. Or you can say x is greater than, you are still writing the same thing. Is greater than 3 over number 1 over 3. Is it different from this? No. In that way, you will not make any mistakes. You will not make any mistakes. Always ensure that your alphabet is positive while you are solving